Number 42. I hope you can see these negatives okay. Sometimes they don't show up well in Word documents and things like that. But those negatives indicate that, each fraction is negative. And we see negative divided by a negative. So, something I can do before anything else is to write these fractions without the negatives, because a negative divided by a negative is positive. I'll put a little plus sign here just to know that we've taken care of the signs. And now let's rewrite what we have. 3x over 5 divided by 9x over 10. We do need to change division into multiplication, the reciprocal, multiplying the reciprocal. 3x over 5 times 10 over 9x. You might notice that I'm no longer writing the plus sign because it's positive. However, if this had been a negative, I would want to make sure I can carry the negative throughout. In this case, it's not necessary. Now, that's 3 times x and 9 times x in those two positions. We can divide out the x's, and then separately we can divide out the 9's. 3 into 3, I'm sorry, the 3 and the 9. 3 into 3 goes once, 3 into 9 goes 3 times. Likewise, 5 into 5 goes once, and into 10 2 times. This is getting very messy, so let's carefully figure this out. In the numerator we have 1 times 2. 1 times 2. I'm even going to write it out there. In the denominator I see a 1 times 3, but I don't see anything else. So I think we're good in calling this 2/3. Number 43, adding like terms. The terms are like, again, because they both have an r squared, but the fractions are not like, because one denominator is 6 and the other is 12. The least common denominator, though, the LCD, is 12 itself. So let's carefully rewrite these. This will be negative 5/12 r squared plus that 1/6. I'm going to leave some space to multiply by, in this case, 2 over 2. Oh, and I want to say that this is equal to what's above. So this is equal to. Now we have negative 5/12 r squared. Notice I put the negative in the numerator this time, plus 2/12 r squared. And when we combine those together, that becomes negative 3/12 r squared. Negative 5 plus 2 is the only thing that we're actually combining, and that's negative 3. And 3/12 can simplify a little bit. So by a factor of 3, we can divide out the 3. Of course, in this case, we've got to be careful. We do have a negative. 3 into 3 goes once, and into 12 goes 4 times. So be very careful what we have here. That's a negative 1/4 r squared. This could also be written with the r squared in the numerator, so it becomes a negative 1 r squared, or just negative r squared over 4. Okay. I just want to make a quick remark here that number 44 is from section 4.4, but it ended up on a different page. So let's scroll down to that other page and see what problem we have to deal with now. So this is number 44. We are asked to find the value of 3/5 of 3 8/9. A couple things going on here. One, 3/5 can be certainly written as 3/5 of. Fraction of means fraction times. And for the moment, I'm going to write that as 3/5 of 3 8/9. However, we can't really do anything with this until we convert 3 8/9 to a mixed, from a mixed number to an improper fraction. So that's 3/5 times what fraction? 3 times 9 is 27, plus 8 is 35 ninths. And again, we have multiplication, so we want to divide out as best we can. Let's see, 3 into 3 is 1, and 3 into 9 is 3 times. 5 into 5 is once, and into 35 is 7 times. And it appears as though we have 7/3, which is an improper fraction, so we write that as a mixed number, 2 and 1/3. In section 4.8, we have two problems to solve here, number 45 and number 46. And in each, we want to isolate the variable. In number 45, we need to divide each side by 42. And so we get x by itself on the right side. On the left side, I'm going to write that a little carefully, negative 28 over 42, but that can simplify by a factor of 7. So let's divide 7 into 28, we get 4, and 7 into 42 is 6. So we now have negative 4/6 equals x, which is fine, except that I want it to be x equals, so I said x equals negative 4/6. Oh, and one more thing. The negative 4/6 can simplify also by a factor of 2. 2 goes into 4 twice, and into 6 3 times. So now we have x equals negative 2/3. Number 46, 3m over 10 equals 2/15. There are a variety of ways to actually solve this equation, but around m we have to get rid of the 3 and the 10. One technique is to write the variable m away from the fraction 3/10. And m, you see here, is a numerator value, and we can see it over here as a numerator value by saying that's the same thing as m over 1. Now, we don't really need that right now, so I'm going to erase the over 1. This now is equal to the original 2/15. To solve, we can multiply, to get m by itself, to isolate. We want to get rid of 3/10, we multiply it by the reciprocal 10/3. Reciprocal 10/3. And what this allows us to do is actually some dividing out right away. 3 into 3 goes once for each. 10 into 10 goes once for each. And we have on the left side 1m. On the right side, we see that 2 and 3 do not have anything in common, but 15 and 10, 5 into 15 goes 3 times, 5 into 10 goes 2 times, and so we have, looks like 2/3 times 2/3. And 1m can be written as just m, and 2/3 times 2/3 is 4/9. Number 47, we need to solve this application. And it says the last event at the Policeman's Olympics is the relay race in which 6 team members, I think that number 6 is going to be important. 6 team members must run an equal portion of a 10.5 mile course. 10.5 is the total, and we have 6 team members running an equal portion. How many miles must each team member run in the relay? This can be solved with an equation, and it can also be solved using straight division. 10.5 divided by 6. 10.5 must first be written as an improper fraction. 10 times 2 is 20, plus 1 makes us 21 over 2. And divided by 6 means times 1 over 6. The reciprocal of 6 is 1 over 6. And we can do a little dividing out by 3. 3 goes into 6 twice, and into 21 7 times. Now we are looking at, let's multiply across. 7 times 1 is 7. 2 times 2 is 4. And as a mixed number, that's 1 3/4. Because this is a word problem, we must write a word answer. And you can see here, each team member must run 1 3/4 miles. Okay, let's look at the very last problem in the set. Before yesterday, Khalil's best long jump was 7 feet 4 5/8 inches. Yesterday he set a new personal best by jumping 7 feet 6 1/16 inches. By how many inches did Khalil surpass his previous best mark? Well, this is subtraction. We need to find out what it is now and what it used to be. One thing that we don't need to concern ourselves with is the 7 feet, because we're saying by how many inches did he surpass his best mark, and 7 feet and 7 feet don't really matter much here. Instead, what we're looking at is the 6 1/16 minus the 4 5/8. That will tell us how many inches he surpassed his previous record. So this is going to be set up similar to the way we set up adding the mixed numbers, where we had 6 1/16 minus 4 5/8. The first thing we must recognize is we do not yet have a common denominator, and that the common denominator is 16. So we'll multiply this fraction by 2 over 2, and then we'll start fresh. We'll see what we have now. Looks like we have 6 1/16, that was unchanged, minus 4 10/16. And notice that the 4 was unaffected by multiplying by 2 over 2. It's just the 5/8. But we still can't subtract directly, and that's because 1/16 minus 10/16 does not subtract directly. So we've got to do some regrouping. Take 1 from the 6 and make it a 5. And that 1 is going to be 16/16. And we're going to add that to the 1/16 that we already have. So let's take another look at this. Our first number becomes 5 17/16. Now minus 4 10/16. Now we can subtract. 7/16 minus 10/16 is 7/16. 5 minus 4 is 1. So what we see here is that he surpassed his previous best mark by 1 7/16 inches. Of course, we want to write that in a sentence, and I have that here. Khalil surpassed his previous best by 1 7/16 inches. Well, I hope this has been helpful to you. I hope that you've learned a lot, or that you've remembered a lot from this, and I hope you do very well on the midterm. If you have any questions, be sure to ask. Good day.